Welcome to the AI in Manufacturing podcast here in Industry 4.TV. I'm your host,
hmm
Kudzai Manditereza, and today we will discuss real-time industrial process optimization and control with artificial intelligence. And to help us unpack this topic, I'm joined by Aldo Ferrante, who is the co-founder and CEO of Sorba.ai LLC, a company that provides the Sorba.ai platform. Aldo, welcome and thank you so much for joining us today.
Thank you for having me.
Awesome stuff. So, maybe to kick things off here, could you begin by introducing yourself and your company to the audience?
Yeah, absolutely. So I've got over 35 years of industrial automation experience, mostly dealing with automated equipment, PLC, SCADA, MES systems, and traditionally, we have been able to use these systems to help enhance productivity. And typically, these systems have been traditionally done using logic-based type controls. And about 10 years ago, I met up with one of my colleagues that we thought about how do we utilize data more effectively. So back in 2014, we had the idea of using machine learning algorithms. And my other partner, Yandi Ramos, which is a PhD in machine learning, we thought, let's see if we can utilize data in a more effective way to help improve productivity in manufacturing. So a lot of the decision making was done primarily by humans. So by using AI, we felt we had a way to help industries be more effective. And that was the birth of Sorba.ai, by the way.
Oh, nice. So, maybe this kind of like jump into it. So, kind of like to set the stage here for us, could you start by explaining to our audience the concept of real time AI process optimization and control? What is it? How does it work? And why is it such a game changer in manufacturing?
Yeah, absolutely. So AI in process optimization and control, it's about really leveraging advanced algorithms to improve industrial processes that makes them more efficient, reliable, and adaptive. And in practice, it works by first collecting data from machine sensors and other equipment on the factory floor. And AI algorithms would essentially what they do is those related to machine learning specifically analyze this data in real time that finds patterns and predict future outcomes, and they help you identify inefficiencies or potential failures before they happen. So once AI systems learn the behavior, they can autonomously make adjustments to optimize performance, whether it's either to reduce energy consumption or improve quality or optimize or minimize downtime. Why this is a game changer, traditionally optimization has relied on human experience, which is not only resource intensive, but it also is reactive. Problems are often addressed after they happen. AI, on the other hand, enables proactive and real time decision making, often outperforming human intuition because its ability to process vast amounts of data continuously. The result is a better efficiency, cost reduction, and a competitive advantage. And the beauty of modern AI systems is that it can operate without needing cloud connectivity, making them more secure and reliable for industries that require more on prem type solutions. And in sections like manufacturing, utilities, and transportation, AI process optimization is transforming how businesses operate by enhancing productivity sustainability. So the blend of control and predictions make AI really a crucial element in the future of industrial operations.
Awesome. I mean, this really sounds interesting, and we're going to go into sort of like the depth of it, of exactly how on the Soba AI platform you kind of like blend the control and sort of like AI algorithms. But kind of like how you describe it is really sounds to me like this is something that is broadly applicable to sort of like many industrial sectors.
Mhm.
Could you perhaps share some typical use cases where what sort of like AI driven process optimization has delivered significant value? Are there any specific industries or specific processes where you've seen the biggest impact of AI optimization?
Yeah, absolutely. So AI process optimization has a really a wide range of applications in manufacturing. transforming really traditional practices by improving efficiency. One example is predictive maintenance. This is one of probably the most popular applications for AI, is predicting when equipment is likely to fail. By analyzing these sensors, we can then predict and uh, basically learn when patterns when potential breakdowns may occur. Another application could be in quality control. By monitoring production data in real time, we can ensure that the desired specifications are met. So when we can start to see problems in the quality, we can then be able to apply different corrective actions. Energy is another huge area for use cases. Energy optimization, be able to optimize energy consumption by analyzing energy usage and patterns and adjusting operations that can minimize unnecessary consumption. Industries, for example, like steel and food processing, where energy costs are high, it can translate into significant savings while reducing the plant's environmental footprint. For example, we do a lot in food and beverage, in refrigeration system and boilers, and what the AI does is it tries to learn the ideal operation of that system to recommend how to adjust the refrigeration or boiler that could generate higher efficiency and at the result of reducing energy consumption as well. Another area is supply chain and inventory management. AI can help optimize supply chain by predicting demand, automating inventory replenishment, or improving logistics. And this ensures materials are available just in time for manufacturing while minimizing like overstock or waste. And then the other most important that we get involved with a lot is process automation and control. So AI can help automate complex manufacturing processes by learning historical data to continuously adjust control settings for optimal performance. And for instance, in industries like chemical and pharmaceutical, AI can dynamically adjust variables like temperature, pressures, or mixing times to achieve the best production outcomes without the need of human intervention. So these are just some examples. Again, there are so many, but the ability to create outcomes more effectively, reducing waste, reducing energy, these are the applications that really make sense.
Interesting. Now, I mean, like traditionally, how industrial enterprises have sort of like approached some of the use cases that you've mentioned, whether it's
Mhm.
predictive maintenance or energy efficiency. They've kind of like taken this approach where you collect data from PLCs, like raw data,
Mhm.
chuck it into a data lake or data warehouse, and then you've got like a central data science team that works through the data to try to get the value out of it. And in one of your sort of like content pieces that I read, you highlighted that this is really a source kind of like of major challenges that hinder sort of like AI application development. Could you elaborate for us the challenges with that kind of approach, and then talk to us about strategies or solutions that work well to overcome these traditional obstacles?
Yeah, absolutely. So one of the biggest challenges in industrial AI development lies in the traditional approaches like using centralized data lakes and data science teams. While these setups may work well in theory, in practice, they create several roadblocks, especially in manufacturing and other industrial environments. First, for example, like data lakes, these are often very cumbersome because they aggregate massive amounts of data, of different types of data from different sources, such as machines, sensors, production systems, into a single location. The complexity and variety of this data, it makes it very difficult to clean, to standardize, and manage effectively. And furthermore, latencies involved in transforming and processing all this data centrally can hinder like real-time decision making. This is very crucial for manufacturing. Second, centralized data science teams often become a bottleneck. These teams are usually tasked with developing AI models for multiple departments or facilities across the company. This approach slows down innovation because each AI application has its own specific requirements. And data scientists may not have the deep domain knowledge needed for every unique manufacturing process. As a result, these projects take longer, time to develop and to deliver tangible results. In a fast-moving industrial environments, this delay can lead to missed opportunity for optimization and cost reduction. So another issue is the centralized teams. They tend to create disconnect between the AI developers and the people on the factory floor. Like operators, engineers, and technicians are the ones who understand the intricacies of the equipment and processes, but their insight are often left out of the AI development. This gap can lead to the solution that are technically advanced but impractical and hard to implement in the real world of industrial settings. So the solution to these challenges often involves decentralizing AI development by equipping facilities with the tools to build and deploy AI applications locally. Edge computing, for example, enables AI to run on-site close to the machines, allowing real-time decision-making without relying on centralized data lakes. This will empower local teams to use AI tools that don't require deep data science experience. Industries can accelerate the adoption of AI, improving reliance on AI models and achieve faster ROI. In this way, companies can move more from a centralized, slow moving AI development model to more agile, distributed, and practical approach that fits the needs of industrial environments.
Awesome. So I think now let's kind of like shift to sort of like the Sorba.ai platform, which is kind of like what you position as an AI operating system. Could you explain what is an AI operating system, and kind of like how does it address some of the challenges that you like kind of like highlighted?
Absolutely. An AI operating system is a software platform that's designed to streamline and automate the development and deployment and management of AI application, especially in the industrial environment. Similar to how traditional operating systems manage hardware resources and provides user with a user-friendly interface for running the applications, an AI operating system simplifies the complex processes that are associated with building AI solutions for industrial use cases. Sorba is a prime example of an AI operating system that addresses many of the key challenges for manufacturers face with traditional AI development. This breakdown and how it works and the challenges it solves. For example, it simplifies AI development. Again, one of the biggest barriers to AI adoption in manufacturing is the technical expertise required to develop AI models. Sorba eliminates the need for deep data science and machine learning knowledge by providing a no code and low code platform. And this allows engineers, operators, and technicians to understand the processes, and where they may not be experts, they can build, train, and deploy AI models quickly. And then the other aspect is the edge computing for real-time control. Again, kind of repeating what I said earlier, traditional AI systems often rely on cloud connectivity and centralized data processing. This, of course, leads to latencies and security issues. Sorba addresses this by running models directly on the edge, close to the machines in real time. And this allows for instant decision making and the ability to predict equipment failures and optimize energy usage and other optimization parameters. Integration and with data integration without complexity is one of the key features as well. Many manufacturers struggles with these data silos, as we talked about earlier, and the complex data lakes can slow down AI innovation. Sorba directly integrates SCADA, PLCs, and other automation equipment that eliminates the need for complex centralized data management system. This integration allows for seamless data collection, processing, and application all within the same platform without massive migration or the need for specialized data scientists. And the other point is the scalability across multiple facilities. Scaling AI solutions across multiple facilities can be challenging. A lot of people can build AI solutions, but scaling that solution is very critical. With Sorba, this operating system can provide a framework where models can be easily replicated and fine-tuned across different plants and production lines. This scalability allows manufacturers to quickly implement AI solutions globally without starting from scratch for every location. And the last point I'll make is this continuous learning and improvement. Sorba enables continuously monitoring and improvement of AI models in production. As new data is collected, models can be retrained and adjusted to keep up with changing conditions such as variations in raw materials, machine wear, or shifts in production demand. This dynamic adaptability ensures that AI continues to be a value over time and continuous improvement. So those are really some of the key points that highlight from a high level.
Awesome. So, I mean, kind of like to sort of like linger on that a bit to talk more about the Sorba.ai platform. Can you walk us through kind of like the core functionalities of the platform on how
Mhm.
it kind of like enables users to build these real time AI optimization models or strategies, control strategies, as it were?
Yeah, absolutely. And again, as I mentioned earlier, one of the probably the biggest differentiator, the most significant feature is this no code and low code solution. This really enables these non-technical users like the process engineers, operators, and technicians to build their own AI models. Within Sorba, we have these pre-built templates. These are pre-configured templates that are common used in industrial applications like predictive maintenance or energy optimization, quality control. And this environment is a point and click solution that users can visually create these applications without any coding or very low code solutions. And I'll reiterate, the edge computing is another big component of our solution, this real time processing and the offline capabilities for models that can run on the edge. Sorba can operate in environments where internet connectivity is limited. So this is one key feature. And I'll talk about the unified namespace a little bit after, but the ability to integrate both SCADA, supervisory data acquisition control systems, and industrial control systems into a unified database to allow it to be ready for AI algorithms to be trained. So that data ingestion by collecting real-time data from PLC sensors and this concept of smart SCADA transformation by integrating AI directly into control systems, Sorb enhances the traditional SCADA and transforms it into smart SCADA. So that data component and the data cleansing, I would say that probably 70% of any AI development is spent on data by, unifying, collecting, harmonizing the data, cleansing the data, which is a huge, huge problem for most AI developers. Sorba has the distinct ability to automatically cleanse. We have a feature called the Auto ETL. As we ingest data, we automatically are cleansing the data and eliminating any problems in the data to make it very, very quick development for AI solutions. And we've also developed we call our simplified way to train and deploy models. We have a feature called the AutoML engine. So this platform is a way to both design and engineer an entire data pipeline. So it automates the selection, the training, and optimizes the machine learning models. So it basically in an engineering pipeline, you have to split, you have to reduce the amount of dimensions or features. You got to pick the right model. You got to tune the hyperparameters. The entire engineering of the machine learning pipeline is automated with our AutoML proprietary solution within Sorba. And then this continuous learning that allows you to retrain models and fine tune them with new data as it becomes available. Obviously, this ensures that the predictions and optimizations remain accurate as it continues, as changes continues to happen. Predictive maintenance, we have built-in models for predictive maintenance and optimization. So basically, you tell the model what your objective is. The model will then find what the ideal operating parameters are and make recommendations, either what we call in a co-pilot mode that makes recommendations to an operator, or in an autopilot mode that automatically adjusts the set points into the control system directly. Then the scalability, as I mentioned, to basically scale a solution for multi-site rollout. Once an AI model is developed for one facility, it can be quickly scaled and adapted to other locations without starting from scratch again. And customizable solutions for different industries. Like I said, Sorba can work across many different verticals, whether it's food and beverage, steel, automotive, water, wastewater. Sorba provides a flexibility to address industry-specific challenges. And other features like security and compliance, we've incorporated a lot of security within the platform to ensure that it is all the sensitive data is protected for data privacy. We provide role-based as well security to ensure that the proper people are authorized to access certain data, and uh, and so on. So these are some of the things that we see Sorba as a unique tool in the industry. Again, primarily for empowering people that really know the process to build their own solutions, similar to what a PLC does today, right? A PLC or a SCADA system. You're not going to go out and write a C sharp code to develop your own control system. You use tools like a PLC or SCADA to help build these solutions quickly to meet the demands of your production. And Sorba is the same concept for industrial AI applications.
Awesome. So maybe to kind of like use also that analogy about that kind of like PLC development
Hmm.
workflow, kind of like to give sense to members of the audience who might kind of like be considering adoption of Sorba.ai platform. What does a typical ML or AI development and deployment workflow
Hmm.
look like with this Sorba AI platform, and perhaps also highlight what are the timelines involved from conception to deployment?
Yeah, absolutely. It all starts with data. So Sorba begins by data ingestion. And as I mentioned, the ability to connect and collect data from different sources, from even data lakes, from SCADA, PLCs, IoT sensors. So real-time data collection is one of the key first steps. So we use the real-time data collection in order to build the data sets in order to train models, or we can also connect to historical data sets that are already being collected by historians and other database systems. That's the first step. So cleansing that data, automatically cleansing it, preparing it for a machine learning algorithm. Then the data processing, once the data is collected, then we begin the whole process of not only cleansing the data, but also feature engineering, where you may want to define other features within that process that better describes the actual process in the manufacturing area. So that data cleansing, feature engineering, that's one. Then once that data collection and all of data cleansing and feature engineering is done, that's the second step. The third step is then building the model. And as I mentioned, the model selection can either be done manually or by selecting the auto feature, it automatically will generate that model for you to give you the best performing model with the best results. Now, for advanced users, Sorba can also provide flexibility that developers can actually bring in their own machine learning code or machine learning algorithms that will benefit from the platform seamless integration. And you also get automatic data cleansing. So if you have a piece of machine learning code that you've developed over time, by integrating that into Sorba, you get the automatic automation integration and you get the automatic data cleansing as well. That eliminates a lot of the development for advanced users. Then once all that development is done, you're ready to train and validate the model. The validation process starts by getting new data, determining the outcome, this cross validation that the model goes through to make sure that there is no overfitting, uh, generalization of the model. What you want a machine learning model to do is you don't want it to replicate the exact behavior of a system or pattern, because if any inflection happens, the model won't be able to predict. You want the model to generalize enough that will give you the probability of a good prediction. So that is the key for building a good machine learning model. So cross validation is one of those features, and then visualizing the output. So within Sorba, you have a visualization tool that you can monitor the performance and understand what the model is doing. So once you've tested the model, run it through different scenarios, now you can deploy the model online. When we're doing a deployment of a Sorba AI model, we can then test it in open loop. So now we're ingesting real-time data. We're looking at the results as the data is getting processed inside the model. You're looking at the results and determining whether the model is doing what you're expecting it to perform. So the ability to validate in open loop is a very key thing, especially for optimization. When we're controlling a refrigeration system, you can't automatically start adjusting that set point without first determining, is the model recommending a set point that makes sense? And that is also the human in the loop that is doing that validation. Once that happens over iterations over course of time, then we can connect that set point directly to the process and allow the model to directly control the system itself. Within Sorba, you have this what's called model versioning. This whole concept of what we call ML ops is the ability to version machine learning models, ability to track them, to do change management, and a feature we mentioned earlier, the auto learning, the ability to automatically relearn and retrain models without any human intervention is part of that process as well. That all happens after you validate it, the model is working, you can enable this auto learning capability. So this whole real-time analysis and process control, and then the feedback loop that, again, part of the auto learning that self-learns, is a way that the system can then determine, based on new information, it will automatically improve its output, giving you the best result. In some cases, when you retrain a model, part of the feature of Sorba is to decide, if I'm retraining this new set of data, and if the new model is not as optimal, or the performance is not as good as the previous one, it will automatically decide to roll back. So you're always getting the most and the best performing model. So, I mean, there's a lot of aspects to this. We include data drift, of course. We look at the prediction drift. We analyze the actual the performance of the model while it's running. And these are all the features that you get out of Sorba. And based on those outputs, you can determine to retrain and improve. So these are all aspects that a machine learning engineer has to go through, that we've really automated the whole process within Sorba. It really is a product that will accelerate that whole life cycle of developing an AI application.
Awesome. So maybe just kind of like as a follow-up question to that, um, how much? So this is, my understanding, really targeted at sort of like subject matter experts, right? The process
hmm
engineer. How much of data science expertise or appreciation do they typically need to sort of like kind of like build a model or build a system, an AI optimizer system on Soba? Would you
Yeah,
say?
that's a good point, because you also asked about the timeline and how long
Yes,
it takes,
yes,
and I didn't
yes.
answer your question there. I'll give you an example. When we were part of a pilot where a company was evaluating several different companies, their main issues were, how long does it take to develop and deploy a model? And can I support it internally? So every customer, just like in a control system, after the system has been developed, they need the ability to, maintain the system themselves. So can they maintain the system? Can they make adjustments to the system without having to hire a company full time to manage that? So when we did this pilot, we were able, it was a refrigeration system. We were able, from the start to creating results in less than 6 weeks, from start to finish, develop and deploy and show results in a full AI. Where I can tell you from our competition, most of the average timelines were anywhere from 12 to 18 months. So that reduction from 12 to 18 months to 4 to 6 weeks was a main game changer for the customer, and they saw the advantage and the value of Sorba that can really help to accelerate their adoption to AI. And then, because it's all menu driven, by training their internal people, they could easily manage and take over the application without having us full time to manage that application. So that is an example of the timeline. Typically, as I said, if you need a subject matter experts, because we may not be experts in food and beverage or steel, by getting feedback from that subject matter experts, you can deploy a model in really weeks, and that's a reality. So to make that statement is very aggressive, because we can actually not only do we say it, but we've done it.
Awesome. Yeah, so I think this is kind of like good segue into talking about real world examples of case studies. So could
Mhm.
you perhaps
Yeah,
share examples of real world case studies where you've kind of like successfully implemented Sorba.ai, and if possible also kind of like highlight some measurable outcomes, cost savings and things like that?
yeah, absolutely. And as I mentioned earlier, I mean, food and beverage has been one of our flagship applications in energy consumption. In food and beverage, energy is a big issue. So reducing energy and reducing their carbon footprint. So a lot of companies that have a target, sustainability target to meet a certain metric within a few years, we were focused on refrigeration by reducing energy consumption, by actually improving the efficiency of that refrigeration. Ammonia compressors, for example, that was one use case. Another use case in steel, for example, where we were analyzing thermocouples. In that application, we used an AI model to look at the prediction of the thermocouple against the actual temperature. That deviation or that error would indicate either a problem with the process, or it could be a problem with the thermocouples themselves. They may need to be recalibrated in some cases, or just technical issues or equipment issues. And then in the other application in steel, where we had these precision reducing stands, when the when the billet comes out of the reheat furnace in a metal process, the reducers basically squeeze down the metal to iron rods where the finished product gets manufactured. Those reducers tend to be very maintenance intense. Using Sorba, we were able to predict anomalies within that equipment. By predicting a possible failure, they're able to make adjustments in a more proactive way to reduce downtime. And the reheat furnace, any problems that happen in the reheat furnace causes downstream issues. So having that ability to see problems that are occurring before entering the other stage in that manufacturing was a massive game changer for a steel customer, one of our steel customers as well. And there's other areas, for example, in automotive, where we're looking for predictive maintenance issues in the assembly process. In an automated elevator, we are able to predict issues with the elevator that moves the actual car body within the manufacturing process. In a logistics side, we're looking at monitoring cranes and hoists in a shipping terminal to help reduce downtime and predict failures. So there are a lot of use cases, probably too many to mention in this session. Definitely, there are very specific cases where we try to focus on deliverable outcomes. As a company, that's what we try to do.
Awesome. Great stuff. So I mean, one of the other things that I want to sort of like talk about is this idea of OT IT data integration. I mean, as you pointed out earlier on, this really, I mean, revolves around data. It starts with the data, right?
Hmm.
And one of the things that get overlooked by a lot of companies, at least in my experience, that are trying to deliver on the promise of AI, is kind of like sort of like not really focusing on the importance of having that robust and kind of like scalable data foundation.
Hmm.
What in your view are the key considerations for manufacturers when consolidating data from both OT and IT for AI enablement?
Absolutely. So traditionally, OT and IT, they've really operated in silos within the industrial environment. Where OT systems, they deal with more physical side of the operation. They manage machines, sensors, industrial equipment, SCADA, PLCs, MES systems. Where the OT side focuses more on the information systems and platforms such as ERP systems that manage customer relations, that manage, business operations. So AI, to function effectively in these environments, both OT for operating in real time, they must be able to consolidate IT data as well as OT data. This consolidation, this creates a unified data environment that allows AI algorithms to analyze and predict and optimize manufacturing process. That's that whole unified namespace I'll touch upon. If you've heard of the term unified namespace, it's really a way to manage both OT and IT systems. The unified namespace allows you to easily access and address data. It's more of a publish and subscribe using protocols such as MQTT and Sparkplug. This allows OT systems and IT systems to be available to applications like Sorba and other systems as well. Challenges of IT and OT. So these, as I mentioned, these data silos, OT and IT systems are often operated independently. They're stored in separate silos that makes it difficult to extract and combine. And then real-time versus historical data. OT data is typically real-time data, while it tends to be more historical, and IT systems more historical and batch type. And aligning these different data becomes very complicated. Security is another large differentiator. Security and protocol differences where OT systems environments prioritize on safety, reliability, and using like industrial protocols such as Modbus, OPCUA. As I mentioned, MQTT now is also becoming relevant. So in contrast, IT systems, they prioritize on speed and data throughput using common protocols like such as HTTP, SQL Server, and bridging these protocol differences can present a challenge. Like legacy systems, many OT systems are legacy systems and limited connectivity. It makes it very difficult to extract data in a format that is compatible with modern IT and AI platforms. So what steps for effective OT and IT consolidation? And again, edge computing is one of those key strategies. Consolidating IT and OT systems in an edge computing environment. By deploying edge devices on the factory floor, OT data can be collected, processed, and even analyzed locally before they get sent to IT systems. And we had a customer, they were monitoring vibration data, and vibration data is very heavy in terms of payload. So do you want to send every vibration waveform to an IT system that overwhelms the system, both not only from storage and processing, but data, network data bandwidth? With edge computing, you can process that data locally and only send up critical information. So if, for example, you can aggregate that data locally, or you can send critical events like anomalies, for example. These are things that you can do with edge computing, more real-time and data filtering. And again, talking about that unified namespace or unified platform, this can pull data from both OT and IT systems. So this requires using middleware or integration layers that connect different systems and harmonizing the data, and creates a consolidated data stream. So interoperability with OT and IT systems, solutions like Sorba with built-in connectors, and we have both automation connectors and we call them IoT connectors, but those IoT connectors can connect to IT systems. And by unifying that data centrally, we align that data, we harmonize that data, that it is ready for an AI algorithm to train and learn outcomes. So that is one of the abilities of Sorba, is that unification. And an important aspect of OT and IT consolidation, ensuring that data infrastructure is AI ready, as I mentioned. So data lakes and data warehouses, where data lakes can store vast amounts of structured and unstructured data. It makes it easier to feed a diverse different types of data, where data warehouses are often more cleaned and structured data used for business reporting and analysis. Cloud versus on-prem, you have that dependency on security issues and latency, regulatory needs in certain industries. Companies can choose cloud platforms to store, or on-prem solutions as well. What we like to promote is more of a hybrid approach. A lot of our customers and how we go to market is, say, start on the edge, start collecting the real-time data, collecting some IT data on-prem, and then once you're scaling and you want it to centralize, now you can create a hybrid by combining cloud or centralized management with edge devices. This approach is a better way to do this, both from a optimization and more efficient way to manage and process data. And again, security. The biggest difference in IT and OT becomes integrating, and security becomes more critical. There you should not compromise security. And as we open up these systems, data security protocols must be enforced and implemented. Things like encryption, access control, firewalls that protect OT systems that can move data in and out or between IT environments. And then role-based access as well is very important also. So these are just some of the things that are issues between OT and IT. And a product like Sorba, of course, we can help to manage and mitigate those issues as well.
Awesome. Now, for kind of like manufacturing leaders who are sort of like just starting out on the journey of AI or kind of like thinking about adopting AI, what advice would you give them on how to get started with AI implementation, or what are some of the most common mistakes that you've seen out there that they need to avoid?
Yeah, I love this question because I get involved in this quite a bit. And my my personal position is that we recommend is you start small, but you think big. So one of the most important pieces of advice that I can give manufacturing leaders is start with a small, well-defined AI project that demonstrates very quick wins and clear ROI. So instead of adapting very large AI scale transformation across the entire operation, focus on solving specific problems like predictive maintenance, for example, or quality control or energy optimization in a single production line or department. Start with a pilot project. Choose a pilot project that has a high potential for success and measurable impact. This could be as simple as an AI for predicting maintenance or a critical piece of equipment for optimizing energy, for example. Quick wins. Start small. You can demonstrate the value of AI in a short time frame. These early successes can help gain and buy-in from stakeholders and build momentum for broader AI adoption. First thing you want to do is obviously invest in data infrastructure. As you know, AI relies heavily on data, both quantity and quality. So before diving into AI, ensure that you have a data infrastructure that is capable of collecting, storing, and processing the right kinds of data for your equipment. So sensors, some cases you want to be able to add sensors to ensure that equipment is equipped with sensor capabilities to gather necessary data like temperature, vibration, pressure. Many legacy machines can be retrofit with IoT sensors these days because the cost of IoT sensors have come down dramatically. And then data management. Implement centralized data management strategies that consolidate data from your OT and IT systems, as we discussed earlier. And platforms like Sorba can help you integrate and manage real-time data from SCADA, PLCs, and IT systems into a unified environment or unified namespace. And then select the right case studies. So choosing the right AI case study is critical to achieve meaningful results. So look for areas in your manufacturing process where inefficiencies, downtime, or variability are causing bottlenecks or increased costs. So predictive maintenance, process optimization, quality control. These are some of the areas. And of course, embrace edge computing for real time. To enable real time process optimization and control, so manufacturing leaders should consider investing in edge computing. And edge computing enables AI models again to run directly on the factory floor. So real-time adjustments, reduced latency, these are all the advantages as we kind of repeated over and over. And then, prioritize on no-code and low-code platforms like Sorba itself. This empowers your workforce, as we mentioned, and it lowers the barrier to entry for your team and focus on integration and existing systems. All AI solutions should integrate seamlessly with your existing infrastructure, particularly with SCADA, PLCs, MES, and the goal is to leverage AI to enhance your current operation without causing disruptions. So non-intrusive approach to integrating AI. You don't want to go in and start changing your whole architecture. You want to have AI be more of a supervisory control looking over your system as opposed to, re-architecting everything. So seamless integration, minimal disruption. And then cross-platform teams require that all AI projects are most successful when you involve collaboration across different teams. This is really, really important because culture is hard to change any kind of new technology that you introduce. So it's important to create cross-functional teams that bring together domain expertise, operations, IT, and the leadership to ensure alignment between AI innovation and business goals. So collaboration between OT and IT and engage operations as well. And of course, we mentioned prioritize security, establish, this is another key thing, every time we get into a pilot or a project, establish KPIs and measurable ROI. So before starting, it's essential to establish clear KPIs that allow you to measure the success. KPIs could include reduction in like downtime, improved product quality, or energy savings, as we talked about. You want to track the performance, continuously monitoring the AI performance and adjusting to establish the KPIs to ensure it's delivering the expected value, and then measure the ROI. And after the project is deployed, you calculate the ROI by comparing the AI driven improvements against the cost of the implementation. So invest in continuous learning and improvement, ongoing model training, scalability. For manufacturing leaders getting started with AI optimization and control, this requires strategic approach. By starting small and investing in the right data infrastructure, selecting high impact use cases and leveraging no code AI platforms like Sorba, manufacturers can begin to really reap the benefits of AI without being overwhelmed with the complexity.
Awesome stuff. Now, to kind of like conclude this session, I'd like to get your thoughts on what you sort of like see as the future of AI driven process optimization in manufacturing over, say, few years. I mean, things are moving so fast nowadays.
Yes.
It's hard to really predict things 5 years from now. So maybe just kind of like in the foreseeable future, where do you see
Mhm.
things moving? And I kind of like didn't get a chance also to ask you about what the role of generative AI also is within your platform. So maybe if you could kind of like touch both.
Absolutely, yes. So the future of AI and it really is going to drive the shift towards what they call hyper personalized and autonomous manufacturing, where factories will be able to produce highly customized products and scale at scale with minimal human intervention. So things like generative AI, and by the way, we actually incorporated generative. We use what's called synthetic data within our technology that helps to improve the performance, but we are also incorporating generative AI to help not only be able to use the product more effectively, but in the future to make recommendations. So when a model makes a prediction, the generative AI can translate that into these are the actionable steps that you want to take. So, for example, if the AI is predicting a anomaly or a possible failure, the generative AI can make recommendations on these are some of the steps or sometimes the root cause analysis where you can determine what caused the failure. So generative AI is definitely becoming an integral part within the future of AI. So customize at scale, autonomous decision making. These are all things that the future of AI will hold for manufacturing. Digital twins, AI, driven digital twins is a huge potential where you're creating, replicas of the physical models. So you can use AI more of a critical roles to simulate and optimize. So real-time simulation, where you can now in a virtual environment or simulated environment, digital twins means different things to different people. When we talk about digital twins, we're referring to data-driven digital twins, where you're taking that data, historical data, and building that replica, and then using that to gain insight. Based on these different production changes, what will be the expected outcome in this virtual environment that I can help improve? And predictive and prescriptive insight. Digital twins can empower AI and offer insight by forecasting equipment failures and prescribing actions, of course, recommending specific adjustments to optimize production. This will help companies to fine tune operations more precisely than ever before. So this increase in edge computing, I think my theory is that the ability to incorporate AI closer to the control environment will be pushed down. And they're already talking about even control systems having integrated AI like PLCs and SCADA, smart PLCs, having the ability to make decisions by adopting, these different types of AI technologies. Not so much, they're talking about AI operating systems, having the control system become an AI operating system in the future. So real-time processing, smart equipment. A lot of OEMs out there are building now using the term smart that incorporates AI that helps improve and reduce downtime and improve overall OEE. And of course, sustainability, energy consumption, or reducing energy consumption and optimization as these systems they incorporate and integrate AI directly, they will become self-aware in how to improve their systems by becoming more sustainable and more energy efficient. They call this circular manufacturing. If you've heard of that term, this allows for reduced waste and the ability to reuse materials back into the manufacturing process. And then the last point is what we call, and you've heard of this before, collaborative AI, and then human augmented decision making. The human in the loop, in terms of will AI replace humans? Not in the near future that I can see. Well, instead, it will help to augment the human decision making to improve the operational efficiency. So, human in the loop is very important. AI will help workers to make better decisions and provide real time insight and recommendation. And as far as augmented reality, AI will also be integrated with augmented reality that allow workers to visualize machine learning performance or machine performance quality KPIs and optimize and make suggestions in real time. And things like self-healing. This is another area where I think AI will be important in the future, where as the algorithms will determine potential problems, they'll also be able to self-heal, be able to adjust the system to prevent a downtime. A good example there, let's say you have a cavitation on a pump. If I can maybe slow down or adjust the pump operational conditions, I can maybe prevent the cavitation and prolong the life of that system without impacting the process. So these are some of the things that you can do from a preventative maintenance. And then the other point is the what we call the AI powered workforce management. So AI will extend beyond optimizing machines and moving into workforce management by dynamically scheduling labor based on production needs, their skill set, and even predictive demands. Dynamic scheduling, safety and ergonomics. So AI supply chain resilience, again, improving supply chain management is a critical part of manufacturing operations. AI will make supply chain changes more resilient to disruptions by providing real-time visualization and predictive capabilities. So having the ability for end-to-end visibility and that can mitigate disruptions will help, AI will help to improve this in real time. And again, kind of like the same theme we've been talking about since the beginning, democratizing AI in manufacturing. So this ability for, as these systems become, easier to use, these no code and low code platforms like Sorba, as they evolve, more manufacturers will adopt AI and that provide these tools to engineers, operators, and technicians to build and train and deploy their own models. And then you'll see a term called AI as a service, where you'll have models in the future to help lower these barriers to entry that will allow manufacturers to implement AI as a service. And then the last point is this collaborative AI with robots. AI and robotics will become increasingly intertwined, leading to a future where autonomous robots powered by AI can collaborate with humans on the factory floor. So smart robots and human robot collaboration. So at the conclusion, I mean, the future of AI and uh, and process optimization and control is incredibly promising. As AI technologies become more advanced, manufacturers will benefit for smarter, more efficient and effective, and more autonomous production processes. And by leveraging edge computing, digital twins, AI-driven energy optimization, and human augmented decision making, the industry will see increased productivity, sustainability, and flexibility. And manufacturing leaders who embrace AI today will position their organization to thrive in the future, where data-driven insights and autonomous systems will shape the landscape of this global production and manufacturing. So I'm excited about the future, and I think we are really going through a paradigm shift of how we implement AI and intelligence into our manufacturing. So I'm excited.
100%. Yeah, I mean, this really is a exciting time, really, and kind of like the reasons why kind of like we also focusing on AI in manufacturing on this podcast,
Hmm.
because we see this impending shift. So
Hmm.
certainly exciting times. So yeah, I mean, we'll definitely provide links to your website and some of the sort of like content pieces that we referenced here in this
Hmm.
session. But do you perhaps have any last words for our audience, or anything that we didn't touch today?
Yeah, I mean, don't be afraid of learning new technologies. Be in a continuous learning environment, because I think a lot of people are scared of AI, as you know, the fear of replacing people. And you remember, before the internet, everybody was afraid the internet was going to remove jobs. And what it did is it's making us more efficient and more effective. So think of it as you have to be in a state of mind where you're constantly learning, and don't be afraid to adapt these new tools. So be be upfront, be forthcoming, and always be proactive in your personal development, because it's all about still about people today. And with today, I don't know of any future where we'll have the Skynet being able to control everything. I think we're way beyond in the future for that. But I think it's the outlook is very promising.
Awesome stuff. So Aldo, thank you so much for taking the time to come out on this show and share your insights with the audience. Really appreciate it.
Thank you.